Okay, in primary coil, alternating current produces an alternating magnetic field. Alternating current produces an alternating magnetic field. Iron is a soft ferromagnetic material. It can be magnetized, demagnetized, and remagnetized easily. Iron core transfers magnetic flux and its variation from primary coil to secondary coil efficiently. So why do we use iron core? Because iron is a soft ferromagnetic material and very easily, very efficiently transfers the magnetic field and its variation from the primary coil to secondary coil, because magnetic field is varying in the primary coil. We are not using a direct current. We are using an alternating current. Alternating current increases, decreases, changes direction. So the magnetic field it produces also increases, decreases, and changes direction. Very much like current, because magnetic field is produced by the current. Now,
सर जरा सा ऊपर जाएगा प्लीज. नहीं डायग्राम पे जी. ओके थैंक यू.
now, in secondary coil, magnetic flux changes and it induces an alternating EMF in secondary coil. So in secondary coil, alternating EMF is produced because of the magnetic field lines are cut, and this magnetic field lines are changing because of the alternating magnetic field in the primary coil. There is an alternating magnetic field in the primary coil because of the alternating current. EMF induced in secondary coil depends on number one, EMF, EMF in primary coil. Number two, ratio between number of turns in number of turns of primary coil and secondary coil. Note, EMF in secondary coil is 90-degree out of phase with EMF in primary coil. This is because induced EMF depends on induced EMF depends on rate of change of magnetic flux. So
सर वो एक मिनट प्रीवियस पेज की पिक्चर लेनी थी स्टिकर वो ब्लैक में भी जो लिखा हुआ है उसके पास वो भी सर साथ परफेक्ट सर थैंक
this is primary coil, and in primary coil the variation of EMF is like this. So this is happening in primary coil. Okay, this is voltage in primary coil in volts, and this is time in second. Now, what we should expect in secondary coil? Here we go. Okay, the thing is that rate of change, you can get it from the idea of the gradient. Look, from this part to this part, I'm talking about this is zero because this is one time period. So this will be 1/4 of time period. This is 1/2 of time period. This will be 3/4 of time period, and then that will be one time period. So from 0 to 1/4 of time period, you can see there is an increase in voltage, but rate of change is decreasing. If you draw a gradient at the beginning, you will get maximum gradient. But if you draw a gradient at the top, the gradient will be zero. It means the rate of change is decreasing. So in this portion, you should be getting a change which is something like this. Then there will be this. And output voltage, as you can clearly see, is not synchronized with input voltage. Look, output voltage is not in phase with the input voltage. Output voltage is 90-degree out of phase. Okay, so this is the kind of wave you should be expecting for output. Output voltages out of phase by 180. Okay, so this is the output voltage. If you have what do you observe about peak voltage over here? The peak voltage is little less than voltage of primary coil. So So this will be the case where there is a smaller number of turns in the secondary coil than in the primary coil. How this will change if there are more turns in secondary coil than in primary coil. So this is what you should be expecting. If you have more turns in the secondary coil than in primary coil. Number one, you have to be careful in these kind of graphs that it does not depend on how high or low the voltage is or how strong or weak the magnetic field is. It depends on how much change of magnetic field is happening in a certain amount of time. It is the rate of change of magnetic flux that makes a difference. So this is V out in volts, step down transformer. Number of turns in secondary coil is less than number of turns in primary coil. And this is V out in volts. And this is for step up transformer. Number is in primary. That is why voltage in secondary is also more than voltage in primary. Okay. So this will be the end of alternating current. We have studied eddies current. This is something which, yes, we did. This is eddies current. Sometimes it is ignored, but we have done it. Now, this is all of electromagnetism. Okay. Let me share some questions with you that we can solve right now.